According to the European Commission website Climate Action, international shipping is a large and growing contributor to greenhouse gas emissions. The EU estimates maritime transport emits around 940 million tons of CO2 annually, and it's responsible for about 2.5% of global greenhouse gas emissions. These emissions are projected to increase and significantly if mitigation measures are not put in place and quickly. Enter Vancouver innovator and battery developer Brent Perry, who has been on the leading edge of maritime or marine battery development for more than 12 years. He has developed and is deploying a pay-as-you-go electrification service based on swappable e-pod batteries that give shipping customers clean energy. Perry says shipping's retail customers around the world, like Amazon and others, are on board. They want to decarbonize the industry now. IKEA and Unilever have also signed on to the CoZEV pledge, which commits them to decarbonize the industry by 2040. Well, the International Marine Organization actually wants shipping to do it by the end of this decade, a full 40% reduction by the end of the 20s. I invited Brent Perry of Shift Clean Energy to join me for a conversation that matters about his batteries as a service model and how they'll play a significant role in shifting shipping from black energy to clean energy. Brent, welcome.
Thanks very much for having me.
You know, we're living in an interesting time. Like we watched the shift to electrification, and it's as though people up until now have kind of thrown their hands in the air and said, well, there's not much you can do about shipping because the problem seemed so significant. What are the major challenges in being able to develop and deliver a swappable battery solution to shipping customers?
Well, the main challenge is the range the vessels tend to operate within and the fact that they all operate globally with flexible ports and applications that they work in and out of. And frankly, the cost of the technology in some of the markets is not yet really of benefit. But the challenges have now started to be overcome by a combination of what we do with energy storage and power swap, and also innovating other renewable energy sources like fuel cells into the mix to help deliver constancy and real power and real economics to the customers.
Well, the challenges that you touched upon there really are quite significant, aren't they? Especially if you have ships that are going from one port to another or one, jurisdiction to another. How do you, as a ship, arrive in a completely different country and say, oh yeah, I need to swap out my battery? How do you start to make that happen, especially when you look at the scale of the challenge ahead of you?
Well, when we started with energy storage, the reality was you were selling a customer a fixed installation that was very large and very heavy and very costly, and the customer was taking on a tremendous amount of risk to validate the technology and how it works. And we looked at that and said, they don't need to be responsible for the entire risk. If we want to really innovate and flood the market with product today, we have to be their partners and sit beside them at the table and deliver some of the risk management by owning the energy equipment and the charging equipment and the infrastructure that allows the batteries to be charged and put on and off of the ships.
What you're talking about, though, is that you're saying to that ship owner, we'll make the conversion for you.
Yes.
And we'll supply you with the power. You just pay us as you use it. Yes. So you're not taking on some of that risk, aren't you? You're taking on just about all of it?
In a lot of the market case, you could say that, but frankly, the risk in our case is confidence in our product and our partners' products and what we bring to the table. And in the last 12 years, we've deployed over 350 megawatt hour of energy storage. We have a lot of practical history of how it works and the success of its performance. And by taking responsibility of the service and the support and the infrastructure, we actually put ourselves in a less risky position than expecting our customers to do that for us.
Okay, but there's a huge financial upfront cost to you, isn't there?
Yes.
Especially if you're taking a ship. I got thinking about this as I was doing research. Okay, they've got a diesel power plant right at the moment, and you're swapping that out for what?
Well, you're basically replacing it with electric infrastructure on board the ship. and then the battery infrastructure for being able to remove and charge the vessel and operate it, and the infrastructure on shore to manage that infrastructure on the ship. That's why markets like the inland waterways have become first choice, if you want, or the low-hanging fruit of what we do, is that there we reduce the impact of being global. And if you're working on the Rhine River, you have a known travel route that you're doing, and assembling the power swap stations for managing the energy storage is pretty much a much more manageable risk, if you wish. But what we found also is that the combination of legislation, environmental conscience, if you want, societal pressure, and the financial impact of what we do have all come to the place where this is actually less expensive to do than what they're doing today, with far better impact from an environmental aspect. We take a significant number of vehicles off the road, so diesel burning trucks essentially, and provide even our end users, people like a DHL or an Amazon, with a zero emission final delivery of their product from our transfer stations as well. So our pods can actually power the vehicles that will deliver your sneakers and your computers to your house.
You mean in addition to the ship?
Yes.
Okay, so you're delivering them this swappable solution both for the vehicles that they're driving and the ships that they're using.
Yes. And you're absolutely right. The capital risk on our side is extraordinary. Our deployment costs on these systems over the next 3 years will easily go over $750 million US dollars. But the context is that the customers are signing up for long-term contracts. So we're mitigating some of that risk by having a long-term commitment from the partners on the shipping side, and by effectively staking the ground with charging stations so that we can service not only our product, but if any other energy storage systems come along on the waterways, these infrastructure ports will be able to support them as well. So it's all about utilization.
So energy as a service, in essence, is what you're providing.
Yes.
Why not just convert it over and have the ship pull into dock and plug it in, because there's electricity there? Why is this a better solution? Because if we take a look at the Port of Vancouver, they electrified a long time ago. They would have the capacity to deliver that energy. Mm-hmm. What's the downside of doing that versus what you're doing with these replaceable or swappable pods?
It's time. So human nature is not to go slower or step backwards. And while battery technology and lithium has incredible flexibility of charging, the issue is that the high charging rates that you can do to turn a battery around very quickly on board a ship have a very detrimental effect on the life of the battery. So by taking it off the ship for charging, I can charge it at a rate that I literally get 3 times the operational life, put it onto the ship, and now my battery becomes a very long-lived asset in terms of a financial tool. And it also will deliver significantly more energy over life than it would if I were fast charging it. So the issue is simply schedule. So can you afford to give up an hour of charging time when you should be traveling 15 more miles down the road to deliver more freight? And when you're competing with vehicle traffic like trucks that average somewhere in the neighborhood of 40 kilometers an hour total trip, the only way we can compete on the water is if we can operate as close to 24 hours a day in transit with significantly fewer resources operating the vessel and at a speed that delivers the same range or better than what the trucks can do on land. So everything comes down to the financial economics of the value to the customer, which is ultimately all of us at the end of the day. But it's every part of the food chain, the vessel owners and operators, the freight owners and operators, the end delivery companies and operators. All of that has to meet a financial threshold, if you want, where this is less expensive and much better value than what we're doing today. So energy storage doesn't have to be as good, it has to be better. And if it's not better, it has no home in being adopted fast enough for us to make any significant impact to the environment.
So let's say we're talking about that Rhine Riverway that you're talking about, where ships are moving through, they're out loading and offloading, they're in at the dock for a couple of hours at most, I would imagine, because they're moving. How does the swappable battery help them to, I guess, gain a time advantage as well? Because, as you pointed out, time is money. So how does that benefit the ship owner?
Well, the turn time of swapping the batteries ranges from 3 minutes to about 15 minutes.
That's it?
Yes. And that allows them to operate effectively 23 out of 24 hours a day in transit. So the purpose of this is simply to give them the threshold of dealing with the 24-hour day in a 24-hour factor. And payback is driven by frequency of use. So if I only use the system an hour a day, it's very hard to justify the investment. A car is a good example of that. The first owner of the car pays for the battery effectively. In a vessel, we need to have 8 to 10 hours a day of operational time for this to be something that costs less money than what they're doing today. And everything in this business comes down to turning propellers is how you make money. Not turning propellers is not a way to incentivize people to convert from trucks to waterways transit or ports to being fully electric ports. So everything comes down to what do you think can be achieved, but then backing it up with facts and reality and financial support to be able to do that. And 10 years ago, I couldn't have had a financing structure to support a battery installation to save my life. Today, there's numerous green funds available to us, and we have a partnership with some very significant financial institutions who have put a tremendous amount of capital in our hands to be able to deploy on these kind of systems and dominate this space very quickly.
I want to go to the funds, but right at the moment, I'm also thinking about the batteries themselves. When it comes to the cost for energy that you're delivering to the ship,
Yes.
Is it more expensive or is it less expensive than the current, diesel fuel?
Oh, it's less expensive. So
Less expensive.
the delivered energy for us, now it depends upon the matrix of renewables, right? And our goal is to have our renewable energy source, the charging of the batteries, be done with as much zero emission or near zero emission technology as possible, so wind and solar, geothermal effectively. And our focus is on both engaging with those kind of assets on the shore now so that we can buy that energy to charge our batteries from those sources. But then when you combine the infrastructure cost of what we do on the ship and the energy storage system, et cetera, we have to come up with a produced kilowatt hour of energy for somewhere in the neighborhood of 12 cents.
Oh my.
And partly when I go back to the context of how long does your battery last, so if I can get 3 times the cycle life and calendar life out of my battery and work it 3 times as hard in the same period of time, I produce significantly more energy, which equates to far more value in terms of a cost per kilowatt hour.
Are there limitations on the size of ships that you can supply power to as a power plant and then also power with your batteries?
Not really, no. We've designed and built small passenger ferries that carry 6 people, all the way up to right now I'm in the middle of design of a 10,000 TEU container ship that will be zero emission. So there is no limit other than practicality. So if the battery weighs more than the boat, that's a problem. Mm-hmm. And that's when you combine it with a fuel cell or you combine it with an ammonia-driven generator or something like that. That's going to give you the extension of the battery's capability for a much longer range. Mm-hmm. One of the things I think I find most interesting about this is nobody wants to buy batteries. People want to buy a solution. So what we focus on is engineering the entire infrastructure, if you wish, and then we work with several partners who are all leaders in their element of our industry, all marine approved type engineered product, to bring everyone together as a consortium effectively to deliver the best overall value. And it's partly driven by emissions and environmental impact, but frankly, much more substantially by the financial impact that we can deliver today.
Frequently, you get a nice solution like this, and scalability becomes a problem. How did you manage to overcome that?
Well, again, it takes a village to build a house. So Kokum, who are our cell partners, have gone out of their way to accommodate our growth plan in their manufacturing of our lithium cells. So that's probably the single biggest issue is, do we have enough capacity at the cell level? And they've increased their capacity by 20 times in the last 10 years to be able to match the demand of people like ourselves who are creating a commercial market for the product. And they have plans to match our growth strategy for the next 5 years, which is going to be essential if we're going to do that. And then we'll partner with other companies along the way that will also be able to support us in that aspect as well. We have a bill of materials in Southeast Asia that services that market space. We have a bill of materials in Europe that services the EU and Great Britain at this point. And we have a bill of materials in the United States specifically for US-based products and solutions. So we try and match everything up to the current expectation that geography is important. People are looking for local supply where they possibly can have it. And they also at the same time want to be able to touch and service everything that they do. So there's no point in putting product from China in a vessel in the United States because you're not getting a Chinese engineer to fly from Beijing to Houston. You're much better off working with a Houston-based supply chain to be able to service that product in the States or similar in Canada. Mm-hmm. And the goal on our side of the fence is simply to give the customers not just a product that works and a commercial solution that works, but an infrastructure that works and supports their business as well. As our focus on ESG has really increased in the last several years, people are making much different decisions about sustainability and management of what they do. And now, if you don't bring that kind of element of understanding to their business to the table, you're not in touch with your customers anymore and they'll look somewhere else.
Okay, I can't help but try to imagine what's the size of these batteries. You get into a larger ship. What's the size of the battery that we're looking at?
The physical size is about 370 millimeter by 330 millimeter by about 620 millimeters. So,
Okay, I was expecting you to tell me that they're like the size of a semi-truck.
Oh, well, they can be. So the beauty of this is that we approach this business with the idea we don't want to make anything different. The commercial industrial market is a very different space than your phone market.
Yeah.
We don't like retail. We like stuff that stays the same forever. And so we designed a form factor for the energy storage system that you could scale up, down, and sideways without changing anything about how it's manufactured. Mm-hmm. So each one of our batteries, if you want, has a capacity currently of 100 volts. If you want a 1,000-volt system, you put 10 of them in series. If you need to have 100 of those batteries beside each other to meet the capacity of the ship, then you have 100 batteries in parallel, but each one is designed to be completely autonomous and independent of the others. And that gives us a serviceability and a flexibility and a repeatability and a cost management tool to let the volume actually really dictate how we can decrease costs and decrease risk for all of our customers.
Are these contained within the hold of the ship, or are they exposed on deck?
In many locations. So the trend currently is to go to containerized battery systems. So either a container becomes a battery, and I can get about 2.8 megawatt hour into a 20-foot standard container, or they become microgrids where they have all of the conversion equipment to go from DC to AC, and then it's a little less capacity, but then they can be a portable unit. But you are paying the extra cost of the container and the mounting of it. In many cases, we still install fixed battery systems inside of boats because they have the space. The weight down below is better than the weight up on the deck. And it's easier to service and support product inside the ship than it is to have it on a deck where you have to access a container to do that.
Okay, lithium batteries inside a closed container is a bit of an issue from I guess a safety and security perspective. I understand you've gone to great measures to make sure that you're going to mitigate the likelihood of any problems. So what is it that you've done?
Well, that is, I think, the key advantage that foundations everything that we do as a solution. So we developed a cooling technology that effectively completely encompasses the cell, so it has 100% surface area in contact with a cooling surface. And that cooling surface is active enough that I can literally take the heat away from the cell faster than it can generate it. So we didn't try and solve the problems of the world. We just said if we can manage heat, we can prevent thermal runaway and fire and explosion. And our batteries today are the only batteries in the industry that you can visibly see will not blow up under any circumstances. We do nail penetration tests on our website, and that's the worst thing you can do to a lithium battery. And we've always believed that the market doesn't understand our product. It's very dangerous. It is extraordinarily dangerous.
Right.
By demonstrating it and being open book with all the testing that we do and the validation of what we do, the customers don't have to become rocket scientists. They just need to see what actually works. And we challenge all of our competitors, if you wish, to be as transparent as we are, simply because it's important if we're going to engage in a renewable technology and make an impact by 2030 and 2050. The customers have to have the confidence that this stuff isn't going to put their fleet, their bottom line, and their crew and their passengers at risk.
How do you manage to get scale to reach out around the world? You mentioned that you're in the United States, you're in Europe, and you're in Southeast Asia right now.
Yeah. So part of it is based upon the marine industry is small. So everybody has some knowledge of everybody, and we all understand what we're all doing. So when we started this, I had a 30-year track record of being a boat builder. So I'll walk into a room with somebody, I already have credibility. I understand the language, I understand how contracts in the industry works. So we didn't come in as trying to sell you a technology and hope you bought it. We came in and said, look, here's the solution. It's going to have a 2.5-year payback. This is the value it's going to deliver for you. Your 10-year return is going to be this. So we spoke with a lot of confidence about their financial model and their business model. And we always focus on meeting the customer's needs. On the growth side, our strategy is to have channel partners. So we don't really sell anything. We produce, we engineer, we service, we install, and we have global channel partners around the world. And some of our partners are quite large. The NYK group in Japan has, I think, revenues of $6.5 billion, and they're our exclusive partner in the Japanese market. In the United States, we have a partner called ISS, based out of Houston. They have 2,500 service techs already in these kind of industries. So we are leveraging, if you want, the channel partners' knowledge and understanding of the markets they're in and the relationships they've spent decades building up with a product that matches their needs and gives their customers what they need in a much faster sense.
And did I read that you're also working with Port of Singapore?
Yes.
Which is the world's largest port.
It depends on the day, but yes, yeah. Okay. It pretty much is. So Port of Singapore is a unique location. Extraordinarily large, very complex, incorporates every kind of shipping in the world, and it's always backed up. As a source of emissions and pollution, the port represents about 50% of the pollution in Singapore. So it's a significant target, if you want, for emissions reduction.
And what you're doing is demonstrating that as we're moving towards a need for this kind of technology so that we can decarbonize, there's remarkable opportunities and economic benefits that can be realized. Congratulations on what you're doing. Thank you very much for coming in.
Thank you. Well, I really appreciate the opportunity. Thanks very much.